Test 69A, Science, Practice Problem number 1. Problem number 1 is in a data analysis passage. Remember, in a data analysis passage, you don't need to know any prior information. All you really need to do is analyze a graph or a chart. Problem number 1, it looks like the question stem is long and detailed. So it's important that we read and make sure that we understand what the question is asking us. It's important that we underline key information and translate it into your own words. Let's go ahead and get started. 1 says, consider 2 of the riders temporarily renamed Rider A and Rider B. Rider A traveled in the same direction as Rider B throughout the 35-second interval. Initially, Rider A traveled more slowly than Rider B and fell behind. But Rider A pedaled faster and faster, and in less than 30 seconds caught up with and passed Rider B. Who is Rider A and Rider B? They're asking you here, we have in the key Rider 1 and Rider 2. They're asking you which one of these is Rider A and Rider B based on the information that they give you in the passage. And here's what they say. Rider A traveled slower and Rider B fell behind. So which one of these traveled slower and then fell behind? And then it said Rider A pedaled faster and faster and then caught up. So which one? Looks like this one pedaled faster and faster and caught up and passed. So it looks like Rider A caught up and passed Rider B. So it looks like this dotted line is going to be Rider A. And this one will be B based upon the information that we get in here. So that means Rider 1 is the dotted line, which is A. And Rider B will be Rider 2. So Rider B is 2. So that leaves us with answer choice A. Based upon just analyzing the graph here, we can go ahead and translate what it says in the question stem into what the graph says here. Question number 1 is answer choice A. Remember, translate what it says here. Rider A, slow start. Rider B says constant. And then Rider A says finished fast. And that's what you see here, finished fast. Rider A is going to be Rider 1, and Rider B will be Rider 2. Test 69A, Science, Practice Problem number 2. Number 2 says, based on figure 1 and 2, which riders did not begin the 35-second interval at point P? Let's go ahead and take a look at how to answer this particular problem. First things first, let's go up to figure 1 and 2. When you scroll back up to the top and take a look at figure 1 and 2, we see figure 1 here, and we are looking for point P. And in the x-axis, we see the x-axis is t seconds. Then we look at the y-axis, and it's d meters. We're looking for P. And we go ahead and scroll back up to figure 2. And we look at the x-axis, and it says t seconds. And the x-axis, and the y-axis is d meters. We're looking for P. So remember, everything in ACT Science should technically be right there in the passage for you. So what we need to do now is jump on into the mini intro paragraph and find out what P is defined as. They're trying to confuse you, so don't get your undies in a bundle. We just simply go in, and here's what it says. Point P was located at one end of the segment D. So D is here. One end of D is either 700 or 0. So I don't see anything at 700 here. And in figure 2, I don't see anything at 0. So that means this line here, which is the mini dotted line, which is rider 4. Rider 4 is not at either end, so rider 4 is in there. I see this kind of weird line here, which is rider 3, so that's in there. And then I see this line here, which is rider 5. So I know that rider 3, 4, and 5 are not at point P, which is any one of the ends of segment D, which is 700 or 0. So rider 3, 4, and 5 would be included. So then I go ahead and scroll to figure 1. And then I see at 200, there is no points there, or there's no riders there. And then I look down over here, and this is an end point, 0. And that line there is rider 2. And rider 2 starts at 0, or an end of D, which is really P. And then this line here starts at 0, rider 1. So rider 1 and 2 would not be included in there. So that means the only riders that would be included in the correct answer would be riders 3, 4, and 5. Now all we need to do is scroll down to problem number 2 and look for an answer choice that says riders 3, 4, and 5, which will lead us to answer choice J. Remember, ACT Science, in the data analysis, it's basically answering questions based off of a graph or a chart. Can you read a graph or a chart? And all you need to do is just look around. All the information is there, right there in front of your face. 2 is J. Test 69A, Science, Practice Problem number 3. Number 3 states, based on figure 2, how far did rider 4 travel between time 0 seconds and time 15 seconds? Let's go ahead, jump on up to figure 2 and take a look. We're looking for rider 4, so let's go ahead and decipher this information. First things first, let's convert over to the red pen. So first things first, here is rider 4. So that means we're right here. We're at 0 here. So here is, we're starting at 600. And rider 4 at 15 seconds is here, which will put us right here. So we need to know between here and here. And this is where we are going to cross. So we start off at 600 at 0. When you just find 0 seconds, you're at 600. And then at 15 seconds, you see that we are at 375. So 600 minus 375 will put us at 225. Just a simple math problem. Now we scroll down and look for an answer choice. It says the same thing in problem number 3. And there you have it. 3 is A. Test 69A, science practice problem number 4. Number 4 says, based on figure 1, the average speed of rider 2 over the 35-second interval was closest to which of the following? First things first, let's go up to figure 1 and find rider number 2. Make sure that you go to the correct area. We're going to figure number 1. Figure number 1 is right here. And we're going to find rider number 2, which is this undotted line. It's the straight solid line. So here's the straight solid line, and we're going from 0 all the way over here to 35. And we notice that when we go from 0 all the way here to 35, that this number here is about 140. So a simple calculation to come up with the average, we will take the y value and divide it by the x value, 140, which is the y value, divided by the x value, which is 35, and that will give you the average. 140 divided by 35 gives you about 4 meters per second, which will give you the average, 4 meters per second. And that is the answer for problem number 4, and that gives us answer choice H. Test 69A, science practice problem number 5. Number 5 says, a student stated that based on figure 2, rider 5 did not travel at all between t 15 seconds and t 20 seconds. Is the student's statement correct? So first thing we need to do is make sure that we go to the correct area, figure 2, and we're going to look at t 15 seconds between t 15 and t 20 for rider number 5. So let's go ahead, scroll on up. We go back up to the top here. We're looking at figure 2, and we find rider 5. Rider 5 is here. It's the dotted line, this dotted line here. And we look between 15 and 20 is here. And we see that in figure 2, between 15 and 20 is right here. The definition here for increasing, remember, is we have time versus distance. So as the time increases, the distance would be increasing if we were traveling. This is going from 15 to 20, so the time is increasing. But here, from 15 to 20, we are not traveling any distance. So we are not moving. When we come back down to the answers, we look at problem number 5, and what does it say? Rider 5 did not travel. Is that true? It is true. Because we did not travel, the distance did not increase. So the correct answer is going to say we did not travel. Yes, we did not travel. That means answer choice C and D can both be incorrect, and therefore will be crossed out. Let's go ahead and take a look at the other two answer choices. Answer choice A says this. Yes, rider 5's distance from point P, 15 seconds, was not the same as rider 5's distance from P15 to 20. It was not the same. Answer choice B says the slope of the graph over the time interval 15 seconds to 20 was 0. The slope, let's go back up there and take a look and see what they're talking about. The slope is the peak right here. Remember, the slope of a mountain looks kind of like a mountain. That is the slope. So the correct answer here is answer choice B, the slope. It's not the distance, it's the slope. 5 is answer choice B. Test 69A, Science Practice Problem number 6. Number 6 states, based on figure 1, what happens during the pupae stage of a gypsy moth's life cycle? First things first, we're going to jump on up and take a look at figure 1. Figure 1, when you glance up at figure 1, you're asked to analyze this particular table. Here it is. Make sure that you go to the right area. In science, that's half the battle. Go to the right area. Then when you look at figure 1, you see that on the x-axis you have months, January through December, and then the y-axis is basically looking here. We have eggs, larvae, pupae, and adults. So how we would read this is, here's what happens. You have an egg, the egg turns into a larva turns into a pupae turns into an adult, then the adult will go and create more eggs. Then the eggs will transform into a larva, into pupae, into adult, and then an adult larva will turn into more eggs. So that's the progression here. You go from eggs into an adult, and adults are the only ones that are going to be able to produce eggs. That's why we're going up, 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 down, 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 and so forth. So when we come over here and start taking a look at some of the answer choices, we know that answer choice F says this. The pupa lay eggs that will hatch in the spring. We look over here. Pupa are not fully adult yet, so they cannot lay eggs. And do they lay eggs in the spring? Well, no, because the progression is from left to right. So if you look over here, that's wrong for 2 reasons, because they have to go from the pupae stage to adult stage. Once they become adults, then they would lay eggs down here, which would be in the fall. So that's wrong for 2 reasons. Let's go ahead and get that out of there. Answer choice 6F is wrong for 2 reasons. Then you look at answer choice G. G says the pupa lay eggs that will hatch in the fall. Come over here, and for the same reason we said F was wrong. We know that the pupa has to turn into an adult before it can even hatch any or lay any eggs. It's immature and not fully grown, so it can't lay any eggs, so that one is incorrect as well. We can go ahead and get rid of that one. Answer choice 6H says an adult is formed through metamorphosis. Metamorphosis means it is changing. And if we look at the chart here, is an egg changing into a larva? And is a larva changing into a pupae? And is a pupae changing into an adult? The answer is yes. So they're Scooby-Dooing you on that one, saying the same thing but using fancy terms. So H is going to be the correct answer. Let's just take a look at J for fun. Answer choice J says a larva is formed through metamorphosis. Is a larva formed through metamorphosis? A larva is formed from an egg, which an egg changes or metamorphoses into a larva. But what about a pupa? Or what about an adult? Half of the picture of this science passage is left out if you choose this answer choice. Now, don't get me wrong. This answer choice is still correct, because a larva is indeed formed through metamorphosis. But that's not the big picture. The better of the two answer choices is H, because at the top of the scale is an adult, not a larva. Does that make sense? When you come back over here and you look at the chart, the big picture isn't a larva. The big picture at the top of the scale, here's larva. The big picture is what? What's the ultimate goal? The ultimate goal here is to become an adult. 6, therefore, the big picture is going to have to be answer choice H. Test 69A, Science Practice Problem number 7. Number 7 says, a student hypothesized that gypsy moth populations peak every 10 years. If the hypothesis is correct, figure 2 indicates that the next peak in gypsy moth population most likely occurs when? First of all, we're asked about figure 2, and we're asked about the next peak. Given more information that talks about 10 years. So let's go ahead and do this. First things first, we're going to come over here and we're going to go ahead and use this information right here, figure 2. Figure 2, we are looking for the most deforestation. So here is the key. Use this to your advantage. This light deforestation, moderate, and heavy. This is the one that we'll use right here. So you look over here and find heavy deforestation. That will be this one over here. And heavy deforestation over here is 25%. That's the most. Here, this one is 1. There's no heavy. There's 3 here. There's 1 over here. This is the one that we'll use. The year on this one is heavy deforestation. In the question, it says there's a hypothesis that says heavy deforestation by this student predicts that will happen every 10 years. Here is heavy deforestation by gypsy moths. Here's the most in 1981. So 10 years plus 1981 would put you at 1991. We're just basically adding new information to the existing information that we have. 81 plus 10 will give you 1991. Problem 7, therefore, will be answer choice D. Test 69A, Science Practice Problem number 8. Number 8 says, based on Table 1, in the test plots in 1981, the average percent deforestation of which of the following trees species was 10 times the average percent deforestation of yellow poplar. Now, listen, this question is very, very, very easy. All you really need to do is follow directions, go in here, and take the information they give you. Number 1, here's the information you need. Go to Table 1. Number 2, find yellow poplars. Number 3, find which one is 10 times greater than yellow poplars. Let's go up there and see what we have. Go to Table 1. Here is Table 1. Right here. Step number 2, find yellow poplars. Yellow poplars is here. Get a number. The number is for deforestation. Deforestation is the column here. Is 5. 10 times more than 5 is 50. Look in here and see which one of these numbers gives you 50. 12, 17, 22, 28, 34, 41. Scarlet oak is 50. Scroll back down. And look for an answer choice. It says scarlet oak. G. ACT Science is really not that tough. All you really need to do is just go ahead and follow directions. All the information you need is right there in front of your face, especially when it comes to data analysis, answering questions based upon a graph or a chart. Most of the time you're going to be dealing with information that you've never seen before, but everything you need is right there in front of your face. 8 is G. Test 69A, Science Practice Problem number 9. Number 9 states, on the basis of the information provided, did the majority of the tree species listed in Table 1 suffer on average light, moderate, or heavy deforestation in the test plots in 1981? First thing we need to do here is run on up and take a look at Table number 1. Table number 1 up here, you'll see it lists off the average. Here's table number 1. And it lists off the tree species and the average percent deforestation. And it looks like we have 62, 55, 50, 45, and so forth. Then what we need to do is we need to try and figure out, and it goes all the way down here, we need to try and figure out, is this light, medium, or is this heavy deforestation? Well, if you look in the rest of the passage, you will see down here, if you combine the results with figure 2, you will see in the key that it gives you a definition of what the author thinks light deforestation is, moderate, and heavy deforestation. So right here it tells us that light deforestation is less than 30%. So let's go ahead and take a look at that. Go back up here. And let's just grab everything that's below 30%. And when you do that, you see that it is the vast majority is under 30%. So it is going to have to be light deforestation. Combine the results. Just because they tell you to go to figure 1 doesn't necessarily mean the answer is going to come from there or table 1. You can find information that will help you out in other different places. So question number 9, the correct answer is going to be answer choice A, but we found the information in the key, which was located underneath figure 2. 9 is A. Test 69A, science practice problem number 10. Number 10 states, based on figure 2, for what year did exactly 80 plots show moderate deforestation? Now kids, bear with me because this is kind of a tricky problem. We're going to have to look around to answer this particular problem here. First things first, we need to go where they tell us. It's figure 2. And we need to try and find out what year 80 plots showed moderate deforestation. So let's go up to figure 2, and here's figure 2. Right here, and we need to find 80 plots with moderate. So moderate is the gray up here. So let's find 80 plots. Okay, 4%. Doesn't say plots. Darn. 4% of what? See that? So what we need to do is we need to add in information from, yep, you guessed it, mini intro paragraph. How many plots were there total? If you have percentages, we're going to have to come up in here into the mini introductory paragraph, and it says here 1,000 test plots. Now, when you come down over here, we are looking for moderate deforestation. We need 80 plots. We have 1,000 plots, and we need to find a percentage. What percentage of 1,000 is going to give us 80? Well, that's an easy calculation. That will tell us 8%. Look over here, 1979. It's 4%. We're looking for 8. That's out. Here's 8% right here. Great. That will work. That's the color we're looking for. That is what we're looking for. So the answer would be 1980. Remember, you have to find information from several parts here to answer this particular question. The mini introductory paragraph, sometimes they will hide essential information. If you feel like you can't answer the question based upon where they tell you to go back to the mini introductory paragraph and add more information in, just like we did here. The correct answer, therefore, for problem number 10 will be answer choice F. We went to figure 2. We found moderate. And then we found out how many plots there were. And then we multiplied the 1,000 plots by a certain percentage to come up with 8%, and then we looked for the gray area that was 8% and came up with answer choice that came up with F, 1980. There you have it. 10 is F. Test 69A, science practice problem number 11. Number 11 states, statement that CH4 is produced through a process that occurs beneath Mars' surface is consistent with a model of. If you go ahead and take a look at passage number 3, it is an experiments problem. Experiments, there are 4 experiments, student 1, student 2, student 3, and student 4. Each student has a different theory about what is happening in Mars and with the CH4. What we want to do here is we want to try and figure out, the gist of the question is about CH4 and where the CH4 is coming from. They're asking us which one or how many of the students believe that CH4 is derived from beneath the surface of Mars. So we have to go into each one of these students and find out what they say. So here's the trick. They may say beneath Mars. They may use different words to say the same thing. So let's go ahead, jump on in, and start checking. Student number 1 says this: indigenous rocks. Indigenous rocks means rocks that are native to the planet. So if you look over here and start reading, beneath the surface of Mars. Well, if rocks originate from Mars, that might say something about that. So if you go ahead, jump on in here and start reading, here's what it says. It says the CH4, that's one of our key words, rises slowly to the surface. Well, if it rises slowly to the surface, where did it originate from? It originated from below the surface. So that means that student number 1 will indeed believe that it originated from below the surface. So that means right away answer choice D can be crossed out. Student number 1 believes that CH4 occurs beneath Mars' surface. Let's jump on in and take a look at student number 2. Student number 2 says that the CH4 came by comets. So student number 2 is out. When you look at your answer choices, anything with the student 2 can be crossed out. So that means A can be crossed out because student 2 is in there. And student 2 is in C. So you can go ahead and cross that one out. We are left with the only answer choice. Answer choice B is the correct answer. Now, let's go in there and just check, just for fun. We're going to look in scientist 3 and 4, student 3 and 4. Here's what 3 says: beneath Mars and below Mars. They say the same thing, which is below the surface. So the correct answer on this one, it's a matter of just hunting around, trying to find out what the key words are. The key words are, we're looking for CH4 occurring beneath Mars' surface. B is the correct answer on that one. Remember, ACT Science isn't that bad. Just don't be afraid of it. All the information that you need to answer the question will be right there in front of you. You just need to go ahead and weed through all the information to get to what you need. 11 is B. Test 69A, Science Practice Problem number 12. Number 12 states, large deposits of methane hydrate are present beneath the ocean floors at various locations on Earth. Based on student 3's model, a major earthquake at one of those locations would most likely cause what? First things first, we need to go down to see what student 3's model says. And when we go down here, here's what student 3 says. Once released, the CH4 rises slowly to the surface where it enters the atmosphere. So, if we have CH4 or methane on Earth, it is going to rise slowly and enter the Earth's atmosphere. Let's go back up to the answers and look for an answer that says pretty much the same thing. And here it is. Answer choice H. CH4 to be released into the Earth's atmosphere. Answer choice F is out because it says changed into serpentine. That's wrong, just flat out wrong. G doesn't talk about anything CO2, and J doesn't talk about CO2, so that is totally off topic. If you look at scientist student number 3, they don't even talk about CO2, so you know that is totally off topic. The correct answer, therefore, is answer choice H for number 12. Test 69A, Science Practice Problem number 13. Number 13 says, Student 4 would most likely agree with the statement that anaerobic bacteria on Earth can produce. We need to go and find Student 4 and see what Student 4 says about anaerobic bacteria. Then apply that to the scenario of the same thing being on Earth. Let's jump on down and find student number 4. When we find student number 4 here, we finger scan or read until we find anaerobic bacteria here. And here's what it says. These bacteria do not require oxygen and generate CH4 from CO2 and H2. So we come up here, we look for an answer choice that says CH4 is created from CO2 and H2. The only answer that says the exact same thing, CH4 from CO2 and H2, is answer choice B. Answer choice A gets it wrong. It's flip-flopped around, the same as answer choice C. And answer choice D says CH4 from CO2 and H2, unlike anaerobic bacteria. But remember, we want to find something that would agree with anaerobic bacteria on Earth, just like we saw with the anaerobic bacteria on Mars. So answer choice D is incorrect because it says the word unlike. We're looking for something that is like Earth and Mars. Answer choice B is the only one that will answer the question correctly for problem number 13. Test 69A, Science Practice Problem number 14. 14 states, suppose it's discovered that fluids having temperatures high enough to alter rock have not been present on or beneath Mars' surface at any time during the past 10,000 years. This discovery most strongly contradicts statements made by which student? Well, let's jump on up here and look at each one of these students. First things first, we know that when we did an overview, the main thing when you're dealing with experiments is to know the difference between the experiments. We have 4 students, and the 4 students are discussing the differences here. Each student has a different opinion or theory. Student 1 says there's indigenous rocks, and these indigenous rocks are changed because there's hot fluids circulating through the rocks. Right away, if you see here there is no hot fluids. Right away, you know that student 1 is the correct answer. If you look at student 2, student 2 says comets. Well, a comet is like a small asteroid or something coming from outer space landing on Mars. So that doesn't have anything to do with the fluid circulating on Mars. So that one is definitely out. And if you look at student 3 talks about minerals beneath the surface of Mars, but it doesn't say anything about fluids. So you know 3 is not in there. And student 4 talks about anaerobic bacteria, which doesn't deal with any fluid whatsoever. So the gist of the question comes down to this. They discovered fluids and the temperature was not hot enough to alter anything. So which one of these theories is going to get bonked when they find there's no fluids that are hot enough? Well, here it says hot fluids. There's no hot fluids. Right away, student 1 is bonked, and the correct answer when you're looking here for 14 is F because of this keyword. Be careful whenever you get long question stems that entail a question more than 3 lines long. Make sure that you weed through this and you understand exactly what you're looking for here. This is 1, 2, 3, 4, 5 lines long, so make sure that you take time to analyze this and kind of put it in your own words. Break it up if you need to. The correct answer, therefore, 14 will be answer choice F. Test 69A, Science Practice Problem number 15. 15 states, if student 2's model is correct, any CH4 from a comet would be uniformly distributed throughout Mars's atmosphere. Is the actual distribution of CH4 in Mars' atmosphere, as described in the introduction, consistent with this distribution? So the introduction is the little mini introductory paragraph, and student 2 says it's uniformly distributed. In the introduction, we're going to have to go back up to the mini paragraph and see what they say and see if it's consistent with the student. Here's what it says. Methane, CH4, has been detected recently in Mars' atmosphere at an average concentration of 10 parts per billion by volume. Above localized areas near Mars' equatorial regions, higher CH4 concentrations of up to 250 parts per billion have been detected. So right away you see that 10 to 250, that is a wide range and it's not distributed evenly. It's ununiform. So that means the answer will be no. Right away we can go ahead and cross out answer choice A and B. It is inconsistent with student 2. So come over here, we take a look at answer choice C and D and look at the difference. C says no because CH4 concentrations vary from less than 10 in some areas to 250 parts per billion in others. Put a dot by that. That's what we saw up in the top. And D says no because a uniform CH4 concentration of 10 parts per billion is found everywhere in Mars' atmosphere. Well, you know that that's wrong because it said up in the top here in the mini intro paragraph 10 parts per billion here and 250. So you know the correct answer for practice problem number 15 is indeed C. Remember, kids, whenever you get a question stem that's longer than 2 or 3 lines, make sure that you translate this into your own words, and then all the information that you need is right there in front of you. You just have to go ahead and weed it out, find where it is. The key word here is introduction. If you can get to the right area and find the information, the answers will fall right in your lap. 15 is answer choice C. Test 69A, Science Practice Problem number 16. Number 16 states, the process described by student 1 is an example of which of the following geological processes. First thing we need to do is scroll on up and take a look at student 1. The second thing I did was take a look at the words selection and try and figure out the verbs or the action words. Here's what it says. CH4 is generated. That means building by hydrothermal processes operating a short distance beneath the surface of Mars. Hot fluid circulates through the basalt and indigenous rocks and alters it into produce, building again, a mineral known as serpentine. This alteration or change produces, makes. See what I'm doing? I'm just basically selecting all the verbs, which then reacts with CO2 to produce. The word produce is in here 1, 2, 3 times, so I know that it is making something. The CH4 rises to the surface where it enters the atmosphere. So I know that something is being made, and then once it's made, it rises to the surface. We can come over here and we can Scooby-Doo this into the correct answer. Start crossing out stuff that we know is wrong. Answer choice F says erosion, which means break down. We're looking for something that's produced or made. Erosion is the opposite. It's breaking down. We're looking for something that's built. F is out. Weathering. Weathering means to break down. If I take my picnic table and I leave it out in my backyard over the winter time, it will get weathered. That means in the spring I'll need to repaint it. Weathering is a process of breaking down. We know that we are going to produce something, so we're building something up. F and G are out, so we move on to answer choice H and J. We're looking for rising and we're looking for producing. H says mountain building and J says metamorphism. Which one is closer to what we're looking for? Are we building mountains or are we changing something? Let's go back up and take a look one more time. CH4 is generated by a process it's circulated through to produce. Doesn't say anything about building any mountains here. It looks like we're just changing something, one thing into another. Alteration is another word for metamorphosis. So right away, the correct answer on this one for 16 is answer choice J. Test 69A, Science, Practice Problem number 17. Number 17 states, consider the information provided about the average concentration of CH4 in Mars' atmosphere. If Mars' atmosphere had a volume of 10 billion liters, how many liters of CH4 would be present in Mars' atmosphere? First of all, this is a very, very tricky problem because this is the key right here. It says this, consider the information provided about the average concentration. It doesn't tell you that. You have to go and find this information. The best place to find something that you don't know where it is in the mini introductory paragraph. The average concentration is 10 parts per billion. We found that in the mini intro paragraph. So now we take 10 parts per billion and we take the new information, which is 10 billion liters, 10 parts per billion times 10 billion liters. 10 times 10 is 100, which will lead you to the correct answer of A. Remember, if you feel like you can't answer the question, go back to the mini introductory paragraph and look around. Maybe there's some information that you're not aware of, and maybe this will give you some insight into the question. 17 is indeed answer choice A. Test 69A, Science, Practice Problem number 18. Number 18 is in an experiments passage, and the question states, according to the results of experiment 3 for green food coloring, at which of the following exposure times was the absorbance measured at 427 nanometers closest to the absorption measured at 603 nanometers? First thing that we need to do is we need to go on up and take a look at experiment 3. So let's scroll on up to experiment 3. We're looking for where the line is going to be closest with 603 and 427. So scroll on up to experiment 3, and we see that experiment 3 is right here in figure 3. We see 603 here, which is this line here, and we see 427 here, which is this line here. We want to find where the lines are closest to each other, and we see the line is closest right here. Also, we see the line closest right here at 12 nanometers, 12 to 16, or at about 3 minutes. 3 minutes or what is that? 3 minutes or 13 minutes. So let's go down to the answer choices and see which one of those pops off the page. In 18, if you look at all the answer choices, there is no 13 minutes. 3 minutes is in there, and therefore will be the correct answer for problem number 18. Test 69A, Science, Practice Problem number 19. Number 19 states, A student claims that a solution of blue food coloring absorbs light more strongly at 603 nanometers than at 427 nanometers. Is this claim consistent with the results of experiment 1 for an exposure time of 0 minutes? First things first, we need to scroll on up and take a look at experiment 1. Then we need to look at the 0 time frame and see which one is higher. Is it 603 or is it 427? The student claims that there's a higher absorbance at 603. So if that's true, then the answer would be yes. If that is false, then the answer would be no. Let's go ahead, scroll on up, and take a look at scientist experiment 1, which is here. And if you look at figure 1, here's the chart. Here's the exposure time from 0 to 16. Here's where we're looking, 0. Here is 427 nanometers, which is this line across the bottom. And here is 603 nanometers right here, and that's this line here. So what happens at 0? At 0, we see that 427 is down here at an absorbance of 0. And at 2, the absorbance for 603 is 2. So the absorbance is indeed higher for 603 nanometers because it's 2 as opposed to 427 at 0. And remember, this is the 0 time frame here on the X, and the Y is also 0. Let's go ahead and look for an answer choice that says yes. We can go ahead and cross out all the answer choices that say no. That means we can cross out right away without reading too far into it, A and B. Then let's take a look at answer choice C and D. C says yes because the absorbance was lower at 603. Well, that's not true because 603 nanometers gave you an absorbance of 2 and 427 gave you an absorbance of 0. So that is false. And that only leaves us with D. That's the correct answer. Let's spot check our work. Yes, because the absorbance was higher at 603 than it was at 427, and that is the correct answer, D, for problem number 19. Test 69A, Science Practice Problem number 20. Number 20 says, which of the following graphs best represents the results of experiments 1 through 3 for 427 nanometers and an exposure time of 4 minutes? First things first, this sounds like a lot of information because we have to look at all 3 of the experiments for 4 minutes and 427 nanometers. But wait, we've answered some questions already by now that will give us some insight into this question. For example, do you remember the question just above, problem number 19, that asked us about experiment 1 dealing with 427 nanometers and 603 nanometers? When we looked at figure 1 in experiment 1, we noticed that something weird was happening here. Remember, in figure 1, we said that the exposure time here was on the x-axis and the absorbance was on the y-axis. That the exposure time was from 0 to 16, but we noticed that in the blue food coloring for experiment 1, 427 nanometers flatlined. That means from 0 timeline, 0 all the way to 16 minutes, 427 nanometers didn't do anything. It stayed just above the 0 line. So, we already know that our answer for blue food coloring, our bar has to be right around 0 in our bar graph. So when you come down to the problem number 20, you look at answer choice F. Answer choice F, here is our blue bar graph. And you notice the blue bar graph says we're right around 0.75. Go ahead and cross that one out. This says the same thing in answer choice H. We already know that that's wrong because of specifically just of experiment 1. That's out. And answer choice J is out as well. The only answer choice that's going to get us to the right answer here is this one. Notice the blue bar graph here, blue, is right above 0. G is the correct answer. See how easy we just made this problem? Remember, use the information from the passage and from previous questions to make the question as easy as possible. Everything you need to know is right there in front of you. 20 is G. Test 69A, Science Practice Problem number 21. 21 states, which of the following statements about green food coloring is best supported by the results of the experiments 1 through 3. Green food coloring is, we're going to go ahead and look at all of the experiments, so that means go back to the page. If you look at figure 1, here's blue food coloring. So blue, it looks like 603 is high absorbance and 427 is low absorbance. When we look at experiment number 2, which is yellow, now they're flipped around. 603 is low absorbance and 427 is high absorbance. And when you look over here, it looks like we start at 603 high and then we go low, and then 427 we start middle and then we go low. So what do we know about that? This is kind of a combination of both of them. If we were to take this line here and superimpose 427 right here, you would notice that that is not quite as defined, but it's basically pretty much the same line. Then, if we were to take this blue food coloring line here, and we were to superimpose it over here in the green, you see it's not quite as defined, but it's basically the same line. So what we can derive from that is green food coloring is some type of a mixture. When you look over here, the answer that pops out off the page is answer choice B, is a mixture of blue food coloring and yellow food coloring. Answer choice A says does not react to O3, that's off the topic. C says absorbs light. D says absorbs light. Those are both off the topic. Remember, just simply look at the graphs and see that each one of those graphs looks similar, except that the lines are not quite as large and quite as pronounced. B for 21. Test 69A, Science Practice Problem number 22. Number 22 states, considering the results of experiment 1 at 603 nanometers compared to the concentration of blue food coloring in the solution at the exposure time of 2 minutes, the concentration of blue food coloring at the exposure time of 12 minutes was. First things first, this is a classic ACT trick. They give you a question stem that's longer than 2 lines long. And for the most part, when you read it one time, you have no idea what you just read. You said something about experiment 1, blue food coloring, 603, 12 minutes and 2 minutes. But you don't really understand what they're asking you to do here. You're comparing them. If you look at this closely, here's what it says. They said, experiment 1, look for 603 nanometers. Great, you got that down. Then it says, what happens 2 minutes versus 12 minutes. It's asking you, look carefully here at the last part. It says the concentration of blue food coloring at 12 minutes was compared to 2 minutes. Compare 12 minutes to 2 minutes. Read this carefully and you see that this question, when you put it into your own words, it isn't 2 compared to 12, it's 12 compared to 2. So let's jump on back up. We'll take a look at experiment 1, 603 nanometers. That's in figure 1. 603 nanometers is here. We find 2 minutes right here. 2 minutes, we're at 1.4. And 12 minutes, we're basically at 0. So 12 minutes is lower than 2 minutes. So when you come back down over here, you're looking for an answer choice that says lower. 12 minutes is lower than 2 minutes. So right away we can go ahead and cross out H and J, because if you misread this question stem, you're going to get confused and you're going to choose the wrong one. H and J are out because they're both flip-flopped around. It's either F or G. F says lower because the absorbance at 603 nanometers was lower at 12 minutes than it was at 2. That is right on track and the correct answer. Let's see why G is incorrect. It says lower because the absorbance at 603 was higher at 12 minutes than it was at 2 minutes. Well, you know that that's wrong. If you look over here, that says 12 minutes was higher. Well, you know that that's wrong than 2 minutes. And here is the 2 minute mark. You see that that's just flat out wrong and backwards. The correct answer, therefore, make sure you put it in your own words. It's a classic ACT question. They give you a long question stem. They'll give you 2 parts, 2 minutes versus 12 minutes, and you have to flip it around because they're asking you to compare really 12 minutes compared to 2, but they give you the 2 minutes first. 22, F is the correct answer. Test 69A, Science Practice Problem number 23. Number 23 states, light at 427 nanometers is violet in color and light at 603 nanometers is orange in color. Which of the following conclusions about solution color, light color, and absorbance is best supported by the results in experiment 1 and 2? Blue solutions tend to absorb violet light. First things first, we're asked about experiment 1 and 2. So we're going to need to go back and take a look at experiment 1 and 2. The second thing is we're asked about 427 nanometers and we're asked about 603 nanometers. But here is the trick. They give us new information that we want to add in. They tell us that 427 nanometers is violet and 603 is orange. So let's go ahead and write that in. So the first thing that I did, I went back up here to Scientist Experiment 1 in Figure 1, and I found 427 here, and right next to it I wrote violet. The second thing I did is I found 603 nanometers, and I labeled that orange. Experiment 1. Then I went to Experiment 2, Figure 3, and I did the same thing. 603 we said was orange, so I labeled it. Then 427, labeled that violet. Came back down, and now this is much easier to work with. They're asking you, blue solutions tend to do what with violet light? Let's go back up to Experiment 1. Violet light. Here is blue solution. A blue solution, blue food coloring is a blue solution. Violet light, absorption is here. Violet light in blue solutions is absorbed less than orange solutions. Go back down to your answer choices. So, you know, blue is less than orange. So, it says, violet is less than orange. So that means answer choice A and B both can be crossed out because we saw that in Figure 1. Now, we're left with answer choice C and D. C says, less strongly than orange light, and yellow solutions tend to absorb violet light less strongly than orange light. And D says the same thing, only it says more than orange light. So now what we need to do is we need to go up to Scientist Experiment 2. See what happens here. Experiment 2, we see that violet light in yellow solutions is absorbed more than orange. Violet is more than orange in yellow solutions. Violet light more in orange than orange light. D is the correct answer. You're combining results from both Experiment 1 and 2. The best way to do this, and I'll be honest with you, it's very confusing. When you see information, they start adding stuff in here. The more ACT science stuff that you do, the more you realize that it's very helpful. Take this information, go ahead, write it in on your graph, on your chart, in the information, and then that way you don't have to keep referring back, because part of the thing is just getting confused. It's all about just keeping things in order and organized. Once you see up here in Scientist 1, 603 is orange and 427 is violet, then it's very easy to be able to start knocking answer choices out of there. Once again, the correct answer when you start labeling things for 23, D is the correct answer. Test 69A, Science Practice Problem, number 24. Number 24 reads, according to the results of Study 1, as D increased, what happened to theta? First thing we need to do is go up and take a look at the chart for Study number 1. And Study number 1, the chart is on the top of column 2 right here. It's table 1. Here are trials 1 through 4, and here is D, and here is theta. And it looks like as we increase the distance, theta is going in the opposite direction. So the relationship is negative. It's going in the opposite direction. As D increases, theta will decrease. So we'll look for an answer choice that says the same thing as what we just saw there. Scroll on down. As D increases, theta will decrease. Remember, whenever you see a chart with numbers in it, go ahead and put your arrows in there. It's a lot easier for you to understand the material when you see your arrows. H is the correct answer. D is increasing, theta is decreasing. Once again, when you look at your arrows in the chart, you see arrow going down, arrow going up. Test 69A, Science Practice Problem number 25. Number 25 reads, the amount of charge the students initially placed on sphere A using charged probe was the same for all the trials in which of the studies? First thing you want to do here is look for the charge on sphere A. Let's go ahead and weed through the details. We'll go back up here into Study 1, and in Study 1 it says sphere A and B, and it looks like we put a charge, and the charge is negative 7.5 times 10 to the negative 9th. Let's go ahead and take a look at Study 2. Sphere A and B, and there is a charge of negative 7.5 times 10 to the negative 9th. So Study 1 and 2 are the same. Then we scroll on down, weed through the details, and look at Study 3. Study 3 says sphere A, it's what we're asked about, is placed a charge negative 7.5 times 10 to the negative 9th. So that means Study 1, Study 2, and Study 3 all have the same charge for sphere A. That will lead you to the correct answer of D. Remember, this looks like a scary problem. You just look for some numbers, go in there, and weed through the details. 25 is D. It's really not that hard. All the information you need is right there in front of you, kids. Just weed through it. Test 69A, Science Practice Problem number 26. Number 26 states, suppose that in Study 3, an additional trial has been performed with sphere A mounted on stand 1 and sphere H with a sphere radius of 7.0 centimeters mounted on stand 2. Based on the results of Study 3, theta for that trial would be most likely what size. So basically we're going to do this. We're going to go up, we're going to take a look at study 3. We're going to add in 70.70 for sphere H, and we are going to see what the angle for theta would be. So let's go ahead and scroll on up to 3. And here is study 3. So that means we're going to have to add the new information here in table 3. We're going to add a new trial called H. And it looks like the radius is going to be 0.7. So we're going to try and slide our new information right in here. See that? So we're asked about what the new theta value will be. So we see that if we squeeze it in here, because remember the radius is going to be 0.7, 0.7 falls in between 0.48 and 0.95. So that means the new theta value will fall in between 8 and 11. Take your new information, plug it into the information that you have already, and then look at your answer choices. Let's scroll on down. The answer we're looking for is somewhere between 8 and 11. Scroll on down. And you see, it falls right in your lap. Wow. 26, H is the correct answer. Test 69A, Science, Practice Problem number 27. Number 27 states, suppose that in any of the trials in studies 1 and 2, the student had placed a positive charge on sphere B. How would the direction of the motion of sphere B have been affected? First things first, we need to go back to the mini introductory paragraph and see what is happening here. If you look up here, in the mini introductory paragraph about what is going on, there are, in each trial, the students mounted 2 uncharged conducting spheres D apart from the stand. Then they placed a negative charge on each sphere. So you've got 2 spheres, each have a negative charge. The electrical force between the spheres caused them to move away from each other. So if you look up here, here is what's going on. You've got this sphere, negative charge. You've got this sphere, negative charge. Because they're both negatively charged, they push away from each other. If you put a positive charge on this sphere, and this one remains negative, now these spheres are going to be attracted towards each other. This is just common sense and basic science knowledge. So when you come down over here and you look at the answer choices, you see that spheres are going to move towards each other. That means right away we can start crossing answer choices out that says moves away. A and B are incorrect. C says sphere B will move towards sphere A because opposite charges attract each other. That is the correct answer. Let's go ahead and see why D is wrong. D says sphere B moves towards sphere A because opposite charges repel each other. That is wrong. C is the correct answer. Opposite charges will attract each other. C for 27. Test 69A, Science Practice Problem number 28. Number 28 reads, the results of study 2 are best represented by which of the following graphs? First of all, let's scroll on up and take a look at study number 2. Go ahead and take a look at study number 2. You see study number 2 is right here. Then we quickly look at table 2, and we see that it is a direct relationship. We go negative 3.8 with 25. Then we go negative 1.9, 13, negative 0.9, and 6. The arrows are going in the same direction. Now keep in mind that these are negative numbers. The larger the negative number here, the further away from 0 you are. So that means the smaller it is. So keep this in mind as you go through. And the further away we are from the access point here, if you look over here at the chart, you see that this is the theta and this is 0 over here. So remember, we start off large and we are going from large to small. Do you see that? Trial 5 is up here, and we proceed from negative 3.8 going down, 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 down towards 0. So keep in mind as we're going and looking for a graph that's going to represent that. Right away, the first thing that you can do is you can cross out answer choice H, because you know that that is just flatlining right there. That is totally wrong. Then the second thing you see is this curve. That is totally wrong. We are left with answer choice F or answer choice G. This is going, remember your 0 mark is here. So are you starting at 0 and moving higher, or are you starting here and moving closer towards 0? Remember, your number was a negative number, and 0 is going to be larger than your negative number, because think of it as a number line. If you've got 0 in the middle, a negative number on the left here, and then you've got 1, 2, 3 on the right, you see that we're going from a negative number here towards 0. G is going to be the correct answer, and the reason this is so goofy is because it's got negative numbers in here. Go ahead and take a look at that graph one more time and compare it to table 2, and you'll see the only correct answer when you compare both Q and theta, you see that the correct answer will only be the graph G. Test 69A, Science Practice Problem number 29. Number 29 reads, during a given trial, while two charged spheres move apart, the potential energy stored in the vertical steel wire most likely does what? First of all, potential energy is energy that could be saved or used for later. When two spheres are moving apart, It is doing something to this wire. It's turning this wire and twisting it. So it's storing energy, as it says right here, in the wire. So the potential energy is going to be, number one, increased, because we'll be able to use the energy for later. And it's being increased because the wires are becoming twisted. So the correct answer will say something about increased potential energy and twisting the wire, which will lead us to the correct answer of A. Let's go ahead and take a look at some of the other answer choices that are incorrect. Here it says the potential energy stored in the vertical steel wires is decreased. Well, if you're storing energy in wires, that's not decreasing the energy. When you store energy, you're increasing energy because you have enough energy already. You're storing the extra energy. So D doesn't flat out make any sense. C goes along with that same train of thought. You're not decreasing the potential energy in the steel because you're storing the extra. So answer choice C and D are flat out wrong. Let's go ahead and take a look at answer choice B and see why that's wrong. It says the steel wire is increased because the wire is becoming less twisted. Well, think of it this way. We could do an analogy here. We could twist a rubber band, and you know, the more you twist a rubber band, the more you gain energy, and when you release that rubber band, you'll see it kind of spins out. The more you get energy inside the rubber band. So B just flat out doesn't make any sense as well and goes against common knowledge. A is the correct answer, and just remember the rubber band example we talked about here for potential energy. 29, the correct answer therefore will be answer choice A. Test 69A, Science Practice Problem number 30. Number 30 states, as the alternative PRR increased from 25 Hertz to 175 Hertz over the course of the experiment, the percent of frogs that moved to within 2.5 centimeters of the speaker playing the alternative PRR did what? First of all, go ahead and take a look here at figure 2. So in figure 2, the first thing that we need to do is see what the XY axis is here. Here is the PRR in Hertz, and this is the mean right here. So we've got 0 to 200, and then here is the percent of frogs within 2.5 centimeters of the PRR, and this is the mean right here. So we are going to start at 25 and progressively move to 175, and we want to see what happens to the percent of frogs. So quickly just look. Here's where we are at 25%, right here roughly at 5. Then we move over to 50, and it looks like we increase now to 20%. Then at 75, we move over to 25% frogs. Then we go across the mean, and then we go down a little. So we increase, increase, increase. From here to here is a slight decrease. From here to here, as we continue over on the x-axis, now we're decreasing. And then we come over here finally to 175 and decrease again. So it looks like we are going to increase, increase, increase in the percentage of frogs till we hit the median, and then we are going to decrease. So we are going to look for an answer choice that says the same thing as what we just saw here in figure 2. Increase, then decrease. That will give us the correct answer for problem 30 as being H. Simply just look at figure 2, answer the question. Test 69A, Science Practice Problem number 31. 31 states, suppose that in additional trials, each gravid frog had been exposed to the mean PRR and an additional PRR of 140 hertz. The percent of frogs that would have moved to within 2.5 centimeters of the speakers playing the alternative PRR would most likely have been closest to which of the following? Here is what they're asking you to do. You need to kind of put this in your own words. They're adding a new trial here of 140 hertz. So we're going to need to go up into figure 2 and find 140, which is right here. And see that 140 falls in between 150, of course, and 125. And you see at 150, we're basically, right around 19. See that? And at 125, we're at 25. So we're looking for an answer choice that's between 19 and 25. Those are the two areas that our answer has to fall in between. So just guesstimating, I would say 19 to 25, I'd say 23 or something like that. Go over, take a look at the answer choices, and you will see the only answer choice that's even close to that is answer choice B with 22%. You're given new information that you have to add into the graph of 140 hertz, and that will lead you to the correct answer of answer choice B. It's a very, very common type of question on ACT. 31, B is the correct answer. Test 69A, Science Practice Problem number 32. Number 32 is one of the more challenging, more difficult problems to explain, so bear with me here. Problem 32 states, by marking the frogs as part of the procedure obtained in the 60 recordings, which of the following outcomes was the researcher trying to avoid? First things first, this is part of the experimental design and can be found in the first couple of paragraphs in the beginning. So let's go back up to the beginning. We see passage number 6. The first mini introductory paragraph talks about the type of frogs, female frogs, they're tree frogs. The second one will talk about the PRR and the advertisement calls. We'll need that, but hold off for now. And the third one talks about the researchers, and here's what they say. The researchers located and recorded the advertisement calls of a male frog. Then, after they recorded them, they captured them. Then they marked them, and then they released them. Now, the reason that they recorded them first, captured them, and then marked them, and then released them is you can assume that 60 recordings is probably going to take more than one evening to do. So if they're in the similar area, because it's an experimental design, you can't just go from one tropical forest and 400 miles away. You're going to have to be in the same area. So if you're in the same area, It's the same environment. You might have to do it on multiple nights. If it's multiple nights, maybe you will be in somewhere in the exact same area or close by, and maybe you will hear a frog, then you'll record that, and then if you, let's say we mark on that frog after we capture it like a white letter A on the back of that frog, then like 2 nights later we come back, we hear another frog, we go ahead, record that, and then we capture that frog, and we see on the back there's a white A written on there. We go, oh, we've already recorded that particular frog, so that means we're going to have to record another one. Remember, if you record the same frog over and over and over again, that's not a sample size of 60. So what they're trying to do is avoid repetition of multiple recordings of one particular frog. That's why you want to do it over the process, a period of time. You can assume 60 recordings. There's no way you'd be able to do that in one day, and you can't really change the environment too much. So maybe the frog would jump around to different areas and so forth. So what they're really trying to do here is by recording, capturing, and then marking, and then releasing, what they're really trying to do here is avoid recording the same frog over again, because that is going to mess with the results. So when you come over here, we right away know that we can reduce this down to 2 answer choices. Answer choice F says the researcher was trying to avoid recording a particular male frog only once. Well, we know that they're trying to avoid recording a particular frog multiple times. So F is out. G says the same thing as F, record a particular male frog only once. So you know that that's the same thing. F and G are both out because that's just wrong. That's actually what they're trying to do. And H says this, record a particular male frog multiple times. Because if they record the same frog multiple times, that's going to throw off the mean PRR, which is the definition is the frequency of the sound of the advertisement call of the frog. So we're left with answer choice H and J, which say the same thing, record a particular male frog multiple times. Now, let's go ahead and I'm going to draw something on here just so it kind of makes like kid logic-y sense here. Let's say that we have a number line here, and in the middle we have, how about like 100, just like the chart. And the advertisement mean for the advertisement call is, the average here is, the mean is 100. And say that we get like some weird frog, and the frog has like some squeaky voice, and it makes an advertisement call of, let's say, 55. So remember, the mean here is 100. So if we get some weird frog in here at 55, that's going to start shifting the mean over this way. Well, if we record that weird frog more than once, guess what's going to happen? That mean is going to shift towards the multiple calls. Remember, if you've got 2 calls from this squeaky frog, the mean is going to shift over twice, and it's going to shift over quite a bit, 100 down to 55. So if you look over here at the answer choices here, it says H, record, the researcher was trying to avoid recording a particular male frog multiple times, shifting the mean PRR of the population towards the PRR of that frog's advertisement call. That's the correct answer. We want to avoid shifting the PRR, or the frequency of that particular call, towards the frog that would be recorded more than once. So that's really what they're trying to avoid. And what does J say? It says record a particular male frog multiple times, shifting the mean PRR of the population away from that frog's advertisement. Well, that doesn't make any sense, because you know, if you add 55 and 100, right, you get 155, and then you were to divide that by 2, that's going to give you the mean. So that doesn't make any sense. You're not going away from that, frogs. You're going towards. So the correct answer on this one, just by doing a little bit of simple math for 32, is answer choice H. Go ahead, and if you want to find out the experimental design, it will usually be in the mini intro paragraph. We can reduce it down to 2 choices, and then you can say to yourself, well, what happens? Does it shift towards the mean when we have something repeated, or does it go away from the mean? And the answer on this one will be H for 32. Test 69A, science practice problem number 33. Number 33 states, do the results of the experiment support the researcher's hypothesis? First of all, you have to make sure that you know what the hypothesis is. You can simply go up to the mini introductory paragraph and find that. A way you could do that quickly is by finger scanning. You could come up here and you could finger scan for hypothesis. Hypoth, and you would find hypothesis right here in the second paragraph, and it says this: a researcher hypothesized that a greater percent of female frogs would be attracted to a call with a PRR equal to the mean PRR of a population than would be other calls. So here are the results from figure 2. Are these results suggesting that frogs are more attracted to the mean? If you look over here, here's the mean, PRR. It's this line here. And we have 1, 2, 1, 2, and then these ones over here. We look at the y-axis here. Here is the percent of frogs. Here's your dots, and it looks like as we approach the mean, the numbers go up. Up here, 50 to 150, we're all right around at least 19% or higher, and anything below the frequency of 50 or above 150, it drops off considerably. So the results do suggest that the researcher is correct, saying that the frogs would be attracted to the mean PRR. So the answer on this one will be yes. Remember, if you're asked about the hypothesis and you're not really sure what it is, just finger scan for the word hypothesis, read what it says, and then look at the chart and see if it's true based upon what you see. So right away you know that answer choice C and D are out. It's going to be either A or B. A says yes, a greater percent of frogs were attracted to an advertisement call with a PRR of 100. That's what we saw in figure 2. So that's the correct answer. Let's take a look at why B is wrong. Yes, a lesser percent of frogs were attracted to an advertisement call with a PRR of 100 hertz. Well, you saw that from figure 2. That's just flat out wrong, even though it says the right word. Yes, this is incorrect. Answer choice A is the correct answer based upon looking at what the hypothesis is for the researcher and taking a look at the results by simply looking at figure 2, the data. 33 will be answer choice A. Test 69A, Science Practice Problem number 34. Number 34 states, which of the following statements best describes the gravid frogs studied in the experiment? First thing we need to do is go back to the beginning and take a look at the mini introductory paragraph, because it will give you an overview of what we are studying here. It looks like when we come up to passage number 6, it says female frogs here, and there are different calls about fertility. Greater percentage of female frogs that would be attracted to the call. So in the study, we basically have some little box, and there's a speaker at each end. And from the speaker is going to be a male frog calling out. And then the frogs are going to listen to the call. It's a mating call. And the female frogs will start hopping towards either speaker. If the call sounds attractive, they will hop closer to it. If they're not attracted to that call, they will not hop towards it. They will hop away from it, or they will just completely ignore it. So you know that the big picture is about basically mating calls with these different types of tree frogs. So when we scroll on back down to problem number 34, you can see that we are dealing with female frogs. So right away we can cross out answer choice F that says they were male frogs carrying unfertilized eggs. First of all, male frogs really don't carry eggs, so that's kind of wrong in itself. G says they were male frogs making advertisement calls. No, the speakers were making the advertising calls, so that is out. Answer choice H and J both talk about female frogs, so let's go ahead and take a look at the difference. Answer choice H says they were female frogs carrying unfertilized eggs, and J says they were female frogs making the advertisement calls. Well, you know, if you looked at the setup, that the speakers were the ones making the advertising calls of the male frogs, so you know that J is wrong. Answer choice H is the only one that will work. It's the female frogs that are carrying the unfertilized eggs that are listening to the male frogs and their advertisement calls or croaks or whatever they are, and then they will hop towards or away from the speaker depending on if they are attracted to the call or not. 34, the correct answer will therefore be H. Test 69A, Science Practice Problem number 35. Number 35 states, at the start of each trial of the experiment, the gravid frog was most likely placed where? First of all, we need to go up and take a look at the experimental design. So let's scroll on up and look at the diagram. If you look up here, figure number 1 says we have a box that is 1.8 meters long and 1.2 meters wide, and it looks like there is a speaker on each side, and what's going to happen is these speakers are going to play advertisement calls, and they're going to place a female frog in here, and they're going to see which direction the frog is going to jump. So if I put a female frog here and she jumps this way versus that way, we're not really going to know anything. So the best possible thing for us to do would probably put the frog right exactly in the middle, play one of the advertisement calls, and then see what happens. Does the frog jump this way, or does the frog jump that way? We want to basically just put the frog right in the middle, and then that way we can tell which direction they're going to go. If this is a different call than this one, then they would say, okay, well, the frog obviously liked this one better because there was 2 hops to the right. But basically, you want to just put this right in the middle and then see where we're at. What is half of 1.8? Well, half of 1.8 is 0.9. So when we scroll down to our answer choices here, the center of that box will be 0.9 meters away from each speaker, and therefore will be the correct answer. Remember, if you're asked about the experimental design, just go up there and look at some of the diagrams, which usually be in one of the figures above. 35, the correct answer, D. Test 69A, Science Practice Problem number 36. Number 36 says, based on Figure 1 and Table 2, which of the following is the structure of 2-iodopropanic acid? Here's what I did. First things first, we're looking for 2-iodonic propanic acid. If you look up here in Figure 1, you'll see the structure for propanic acid. So let's go on, scroll on up there and just quickly take a look at it. When you look at the figure, you'll see a propanic acid here at the top has 2 hydrogens and an oxygen across the top. That is the definition of a propanic acid. That is different than an acetic acid, which has only 1 hydrogen and an oxygen. There's 2 hydrogens here, 1 hydrogen. So really what we're looking for is double hydrogen and an oxygen. Anything other than that, we can go ahead and cross it out. Let's go on back down to problem 36 and start looking at the answer choices and crossing stuff out. If you look at answer choice F, you see that there's only 1 hydrogen and an oxygen. That is an acetic acid. Cross it out. Answer choice G is 1 hydrogen and an oxygen. That is also an acetic acid and can be crossed out. Now, if you look at the rest of the answer choices, H and J, there is 2 hydrogens and an oxygen. That's a propanic acid. And J, 2 hydrogens and an oxygen, which is a propanic acid. Now, what we need to do is we need to put the iodine, or I, on the second position. So when you come over here, if you look here in answer choice H, iodine is on the first position. We need it on the second. Over here, iodine is on the second position, and therefore the correct answer choice is going to be J for problem 36. Test 69A, Science Practice Problem number 37. Number 37 states, based on Figure 1 and Table 2, the structure shown below has which of the following formulas? Well, even if you don't look at Figure 1 or Table 2, you can use a little kid logic or geniusness here. First of all, here's what we see. The structure here, there's a hydrogen on one end, and then there are 3 carbons in a row with an oxygen at the end and then another hydrogen attached to that. So right away when you come down to answer choice D, you see it says carbon and then 3 hydrogens. So quickly glance in here and you see that supposedly answer choice D has a carbon with 3 hydrogens surrounding it. Well, look in here. Carbon number 1, there is only 2 hydrogens, so that's incorrect. Carbon number 2, there's only 2 hydrogens. And carbon number 3, there is no hydrogens. So that basically tells you that there is no such thing in this structure as a carbon with 3 hydrogens surrounding it. So therefore, D can be crossed out. Well, with the same logic, if we carry that forward, we can also cross out answer choice C, because C starts off with carbon and 3 hydrogens as well. If we look at answer choice B, B says bromine and, what do you see there? Carbon and 3 hydrogens. There's no such thing as carbon with 3 hydrogens surrounding it, so that must be incorrect if you take a look at the correct answer, which is A, bromine, carbon, 2 hydrogens, carbon, 2 hydrogens, carbon, oxygen, oxygen, hydrogen. Let's go ahead and breeze through here and do a quick overview of some basic organic chemistry. Number 1, in position number 1, you have a bromine. Bromine is down here. Next to the bromine, you have a carbon with 2 hydrogens connected. Here is your carbon, and here are your 2 hydrogens. Then, next to that, you have another carbon with 2 hydrogens. Here's your next carbon, and it's surrounded by 2 hydrogens. So far, so good. The next thing you see here is a carbon with a carboxylic acid, or OOH. Here is the carbon. Here is the carboxylic acid, OOH. There you have it. A is the correct answer. Basic Organic Chemistry 101, 37. A is the correct answer. Test 69A, Science Practice Problem number 38. Number 38 says, consider the structure below. Based on figure 1, if the Ca with this structure were listed in table 2, the atom represented by the X would be what? First thing we need to do here is let's go on up, take a look at figure 2, and see what this structure is similar to. When we scroll on up and take a look at figure 2, we see we have acetic acid and propanic acid. And remember, acetic acid will have an H and an O on the top here, and a propanic acid will have HHO on the top. On the bottom of an acetic acid, you will have a Y group connected. If you look here in the propanic acid group, on the bottom, you will have an X and a Y position at number 1 and number 2. So when you scroll down here, the first thing that you need to do is you need to identify, is the structure an acetic acid or is it a propanic acid? Scroll down again, take a look. Do we have a double H and an O, or do we have a single H? In 38, the first thing that we notice is there's an HHO at the top. This means it's a propanic acid. Then on the bottom of a propanic acid, remember we have the first position, number 1, is known as the X. In the second position, let's go ahead and write it in. In the second position is known as the Y. This question is basically asking you which one of these is the X value. The X value, how easy is that? The X value is the iodine. Let's scroll down to the answer choices and see which one gives us the answer. J falls right in your lap. Once again, remember, once you identify this as a propanic acid, because the structure has HHO on the top, then you notice a propanic acid will have an X and a Y group in the position number 1 and position 2. Then you simply just plug in what the values are for your X and Y. Your X value would be the iodine and the Y value would be the chlorine. Once again, take a look at figure number 1 and you'll see the X and Y values are here. X position 1, Y position 2. Basically just scroll on down. If you have no background whatsoever in organic chemistry, you can still get the correct answer by just searching around. It tells you here to go to figure 1. So simply just go to figure 1 and look around. 38, the correct answer, J. Test 69A, Science Practice Problem number 39. When you take a look at problem 39, first of all, there's some terminology in here that most kids won't know. Second of all, it's rather difficult to read. So what we can do is we can go ahead and cut out information that's not important. If you look at this particular question stem here, you'll notice that from here, starting with the word A, 1.0 M aqueous solution, you can go ahead and cross that out, because that's what everything is going to be set in. The question now becomes, according to table 2, acetic acid or propanic acid is more acidic. You're asked which one of these is more acidic. Is it propanic acid or is it acetic acid? Now, let's do a quick overview of some basic chemistry. We have pH, which is the amount of acidity. It will run from 0 to 14. 0 being the most acidic and 14 being the most basic. Right in the middle, neutrality or balanced will be at 7. What we need to do now is we need to run into table 2 and we need to look at acetic acid and look at the number, put it in our little scale here to see where it falls in on the acidic scale, and then we need to go ahead and find basic propanic acid, throw it into the scale here, and see which one is closer towards 0, because remember 0 is the most acidic. Let's jump on up, we'll take a look at table 2, and we'll first start off with acetic acid. When you come up to table 2, you see that acetic acid is on the top here. Let's go ahead and take a look at the pH. The pH here is 2.38. Remember, acidity is the closest to 0. Now we'll compare that to propanic acid here, and we'll see the pH on this one is 2.44. So right away you can see that acetic acid has a lower pH, which means it is more acidic. The correct answer, therefore, when you throw it into the scale, acetic acid will be closer to 0, and therefore acetic acid is the correct answer. We can go ahead and cross out answer choice C and D. We're left with A and B. Let's go ahead and take a look at A. A says acetic acid because the acetic acid solution has a higher pH. Well, you know that's incorrect because acetic acid had an actual lower pH of 2.38 compared to 2.44 propanic acid. So that gets its terms mixed around. Let's take a look at B. B says acetic acid because the acetic acid solution has a lower pH, and that's the correct answer. Remember, two things to review here is the scale of pH and basic versus acidic versus neutrality. Acidic is 0, basic is 14, and neutral would be 0. When we're asked to weigh which one is more acidic, the one that's closest to the 0, the lower number will be the one with the most acidity. In this particular case, acetic acid versus propanic acid we saw that when we went to table 2, acetic acid was the one that had the lower number and therefore is more acidic. B for problem number 39. Test 69A, science practice problem number 40. Number 40 states, fluorine is the most electronegative of all elements. Based on table 1 and 2, the pH of a solution of fluoroacetic acid would most likely be what? First thing we need to do is scroll on up to table 1 and table 2. So we don't have, in table 1, we don't have fluorine, so we're going to have to look for something close to that. If you look over here, the first thing that we notice is we have chlorine, and the electronegativity of chlorine is 3.44. Now, let's jump on down and see what happens to the pH of chlorine in something that we're looking for here. Here is chloroacetic acid, which is very, very similar in structure to fluoroacetic acid, which we're looking for. So the electronegativity is 3.44 on chlorine, and chloroacetic acid, the pH is 1.44. Now, when you come over here and we take a look at bromine, we notice that the bromine electronegativity goes down. We are now at 2.96. So what happens to the pH when we throw it into an acetic acid solution? Bromoacetic acid produces a pH that is now higher, 1.46. So this denotes a negative relationship. As the electronegativity goes down, the pH will go up, an inverse relationship. Let's go ahead, take a look, make sure that we're on the right page. We continue on down the line here. We look at iodine. Iodine, the electronegativity goes down. We're now at 2.66, so we can anticipate that if we throw iodine into an acetic acid, that the pH is going to come up. Here we find ioacetic acid, and we see that indeed the pH now comes up to 1.59. So, in the question, problem number 40 tells us that fluorine is the most electronegative of all the elements. So when we come up here, we look at chlorine, which has an electronegativity of 3.44. We already know that fluorine is higher, so that means the inverse relationship means that the pH for fluorine is going to have to be less than chlorine. So the pH for chlorine, when we throw it into an acetic acid, is 1.44. So that means that fluoroacetic acid will produce a pH of something less than 1.44. Let's jump on down to the answer choices as we predict the answers. Answer choice F, less than 1.44. Right on, Thomas. Remember, all you really need to do here is follow directions and take a look at table 1 and table 2 and simply plug things in. Another thing is, kids, relationships, positive or negative relationships. ACT science is all about relationships. Science in general is all about relationships. What happens when you do this? 40, F.